Hello everyone. In previous session we have seen the historical development of the optical communication system as there are different 5 generations, and we have seen the technological features and properties of each generation. Now let's consider which different elements are needed if you want to just install optical system. Mainly it consists of 3 elements. One is optical transmitter, which consists of drive circuit and the light source. Then second element is the optical fiber, which can be a multi-mode fiber or the single mode fiber. Third important element is optical receiver, which consists of photodetector, amplifier, and so on. So these three are the main elements of the optical link. The other elements which are needed includes connector, optical splice, beam coupler or splitter, regenerator, and the optical amplifier. So let's understand the function of the connector. If we just look at the first block, that is a transmitter block, the output of the transmitter, that is light source, is given to optical fiber. So optical fiber is connected to the output of the light source by using the connector. In other words, the connector is the device which can terminate the fiber either at the transmitting end or at the receiving end. If we just look at the other end, the last element of the optical link, that is receiver, the fiber is also terminated or connected to the receiver by using the coupler, connector. So connector is needed at the transmitting end as well as at the receiving end. Then we require optical splice. The optical splice is an element which can join two fibers. So basically it makes a joint of two fibers. So one very important question is, what is the basic difference between the connector and the optical splice? The optical connector is a device which makes the joint of transmitter and fiber or receiver and fiber, while the optical splice is a device which can make a joint of two fibers. The function is same, but the input and output of connector and splice is different. And the splice is an important element which can be used to just implement a long distance optical link. When the distance is in thousands of kilometers, it is necessary to join two fibers. The next link element is optical splitter or coupler. So here the light can be splitted and the output can be taken for the reference purpose or the reference measurement, and it can be given to the mainstream, that is to the regenerator, which consists of different blocks such as optical receiver, then there is an electronics processing circuit, and then there is optical transmitter, and then again the light is coupled to fiber after this processing and then amplified by using the optical amplifier. And such an amplified optical light or signal is given to the photodetector. So this is a basic configuration of the optical system which consists of various link elements. Let's understand the function of each block. The first electrical signal is given to the light source. The light source can be light emitting diode or it can be laser diode. As we have seen in the previous session, in the first generation, the operating wavelength was 850 nanometer. Basically, the source was the light emitting diode in the first generation of the optical communication. Then in the second generation onwards, this LED was replaced by the laser because it offers certain advantages which can make the system reliable and cost effective. In coming sessions, we will be discussing about, we will be comparing the performance of LED and the laser diode and how this particular source makes the system cost effective. We will be discussing that. So what you have to remember here, the selection of the source plays very important role, and designer can have two different options. One is LED and other is the laser diode. So function of the optical source is to convert the electrical signal, which is the input signal, into the optical signal. And such an optical signal is then carried by the optical fiber. The fiber can be glass fiber or it can be a plastic fiber. Depending on the transmission mechanism, it can be single mode fiber or it can be a multi-mode fiber. So such a light which is carried by the fiber is then given to the regenerator. Regenerator and optical amplifier are two important elements of optical link. So let us understand what is the difference between the regenerator and the optical amplifier. Basically, a regenerator is a device which can regenerate the original transmitted signal. As its name indicates, it's a regenerator. If the signal gets distorted due to channel properties, there can be attenuation, there can be some filtering of the signal which can create or introduce the distortion. So this distortion is overcome by using the regenerator. And hence the regenerator first receives the optical signal, convert that into electrical signal. This signal can be processed, regenerated, and again that regenerated signal is converted into optical signal by using the optical transmitter, which consists of the optical source, and then it is connected to the fiber. So such a regenerated signal is then given to the optical amplifier. So optical amplifier is a device which can amplify its input signal. Let's consider the optical link which is implemented without a regenerator. Suppose the 7 number block is eliminated from the block diagram and the output of the splitter is directly given to the optical amplifier. So what can be a problem for such a arrangement or for such a configuration? Suppose the signal is distorted and the noise is superimposed on that signal, then optical amplifier can amplify the signal along with the noise. The amplifier has the ability of amplifying the signal information as well as noise, and therefore it can affect the signal to noise ratio. But the regenerator can overcome the signal distortion and it can improve the signal to noise ratio. Regenerator cannot amplify the signal, but it can maintain the noise level or it can overcome the distortion, and therefore for long distance link the regenerator and optical amplifier are the essential link elements. Such an amplified signal is then applied to the photodetector. Photodetector exactly performs the opposite function as that of the optical transmitter. It converts the optical signal into electrical signal, and that signal can be just given to the destination or user. So in this way, these are the important elements which are needed to just establish or implement the optical link.
थैंक यू.
थैंक यू. ये थोड़ा जमेगा लगता है क्योंकि आदत जो